And I am live. That is pretty nice. So today is 11th of October 2025, Saturday. And with that, let's just start solving questions. 1500 rated questions. And yes, there is one more thing that I have talked with people, and we have come to a realization that the questions at a certain rating, any rating in code forces, are now more difficult than they are at the same rating in CP31 sheet. So yeah, uh, the 1500 rated questions at the yeah, these became doable for me after a point, but there is immense difficulty while solving the same questions at the same rating 1500 in code forces per now. And yeah, that was a bit discouraging, but now it is fine. And yeah, it is whatever it is. If I just keep solving questions, I will hopefully get better. Shit, why haven't I done this question? I didn't even try to do this. This one is, I guess, new. Hidden knowledge of the ancients, deep woken. Okay, let's do this one then. And tmux kill server, tmux set, and tmux attach. With that, let's begin solving questions. Cool. This is going to be the first question. Excalibur. That is crazy. Okay. Okay. Cool. Start and cool. The word deep woken, there in the world of deep woken, there exists an ancient artifact, the table of infinite knowledge. Okay, on which a sequence of n mysterious symbols, each symbol is an integer, is engraved. It is said that the true power of the artifact can only be revealed of finding all frames. Continuous segments of the tablet contain exactly k distinct numbers, and their length must be between L and R inclusive. Formally, given a sequence of A, given a sequence A of length n, integers k, L, n, you need to find the number of such boundaries B and C such that they are like this. And among the elements, there are exactly k distinct numbers. Okay, there are k distinct numbers, and L and R. What is the point? For and this boundary cannot be greater than L and R. Okay, okay. So we have been given a sequence. In the first line, we have N, then K, then L, and R. Okay, N is like all the integers that have been given to us, and K is the number of distinct integers we need, and L and R are tell us how, what is the maximum length which we can have, and there is also going to be the minimum length of integers that we can take is going to be k, because we need at least k integers which need to be distinct. Here the length of a subsegment which we can take is 2. 3 minus 2 plus 1, 2, and we that is the maximum length, and the minimum length is also 2. So we can just check everything, every subsegment of size 2. Here this subsegment, this works. So 1, 2, 3, and 4. Answer for second one should be 4, but it is 5. 1, 2, 3, 4. L and R inclusive. In the fourth test case, there are total 5. In the fourth one, okay. Hello. This is CS50, free course by Harvard for free, and uh, there are lectures for this course free on YouTube, and there are also exercises. And at the end, and this is pretty tough also, and this is for beginners. Like CS50 is Introduction to Computer Science. So this is a introductory course. This is for beginners, and you can take this. And this is pretty cool for a beginner to take. Yeah, you can take this course. CS50 is Introduction to Computer Science. I hope that was helpful. 1, 1. Here the length can be 2, right? So this is one subarray. Shit, okay. Length can also be 1 in this case, but with one length we do not get two distinct numbers. Let's see this one. Here we also have this. A subarray of identical numbers gives exactly one distinct number. The start and end of possible subarrays are length this. For length 1, we have all of these. For length 2, we have all of these. In total 7. In the fifth test case, fifth, the length can be 2, 1, 2, and 3, and we need 3 distinct characters. So minimum length is 3 and maximum length is also 3. So cool. And what do we have? We have this. This thing works. Wait, is it k? There are exactly k distinct numbers in that range. In the fifth test case, length 2 have exactly 2 distinct numbers, and for length 3, we can even go length 4. We can go with length 4, 2, 3, 4. How can we go with length 4? Because 2, 3, 4. We can go with length 4. If we can go with length 4, then here the answer would be 5. Because 3 exactly 2. And yeah, 3 is one thing. Okay, and in here, length 2. Length 2. In this rule, what does this say? This makes sense. This much makes sense. And okay, we have to then choose B and C. And L, what is this value? This value, let's say this is 2 and this is 1. In that case, -1. How do we get to L? C minus B. C minus B. Shit, this makes so much sense. The length can be as minimum as L and as maximum as R. That makes so much sense. How would you learn a language? Learning a language and learning how to program go hand in hand. So, and that course would be like pretty cool for you, because that would also teach you how to think like a programmer, and also they would also teach you a language which is C. Yeah, they would teach you C, and that is cool. You can do that. Okay. Here, let's say For every index, we will create a vector and we will see how many distinct numbers we have seen in that range. Okay. So there are five numbers and minimum length can be the length can be greater than equal to 2 and less than equal to 3. That is how the length can be, and therefore length can be 2 or length can be 3. Those are the only possible cases. And let's see if we will create another array contain which will contain the number of distinct numbers we have seen till the ith element. So at the start, we have only seen one distinct number, which is literally just 1. And also to calculate this, we will to like make this array, we can keep a set that would help us. And till the second index, we have seen two distinct numbers. Then we have seen two distinct numbers. Then we have seen three distinct numbers. Then we have seen shit, three distinct numbers. So this is monotonous. This will keep increasing. But this shit. Okay, this is not good because this thing does not tell us that this number remained 3. It was 3 here and it was 3 here. Which number did we saw here? And if we were to take this range, how many distinct numbers will we see? Yep. How many distinct numbers will we see? That is crazy. Okay. And well, actually here we would see three distinct numbers, but if we were to no, so that is not good. What are the limitations? N can be like very big. That is cool. Here we do see a distinct number. Okay, not this. I think we can. No, no, no. Okay, this has to do something with creating a new vector and sort of like a range query question. Whenever we see a new number which we haven't seen before, then we will add one, or then we will do something with at that place, and we should be able to find out in a given range how many distinct numbers are there in that range. But how do we see distinctness here? If our range is just this much, then one is distinct. But if our range is this much, then one is not distinct. Okay, then one is not distinct. And L and R also can be very, very big, so we cannot brute force. And also, we need to have a length of at least k to have k distinct numbers. Yes, and if our upper limit r is smaller than k, then the answer is not possible. We will output 0. That would be the easy case, but in general, okay, we have to find a way which we can use to figure out how many distinct numbers there are in a given range without going through the thing again and again. And yes, So we have 1, 2, 1, 3, 2, 1, let's say 1, 2, 1, 3, 2, whatever. And now, given a range, how many distinct numbers are there? Exactly. This is not like prefix. If you were to make prefix 1, 2, we have seen two distinct numbers till this point. And till here, there are three distinct numbers. Then again, 3 and 3. But if we were to take this range, we will see that we have only seen one distinct number in this range. If you were, yeah, so using this, we can find out in a given particular range how many new distinct numbers there are from the start. Like among the numbers which we have seen till this point, were there any new distinct numbers? Like, yeah, distinct numbers are new in this given range, and the answer here would be yes. But that is not what we want. We no, no, no. And yes, this like here we have 333, and this is not telling us are we getting this 3 again and again, or are we seeing some other number like 2 and 1. Yes, this has to be a little bit more sophisticated. So yeah, prefix sum is not going to work here. So this has to use something else, something else. And yes, shit, this is 1500. Like whatever the level of the latest 1500 questions is, this is one of these. And yes, this is the, but that is beside the point. Okay, what do we want? We want to know one thing given a range, how many uh, distinct numbers in the range. And let's say we do figure out a way to calculate this. Then what we will have to do? Then we will have to iterate from K to R, and like the length of our subsegment would change from K to R, and this would be linear time, like having a specific length in this range. K to R is having a specific length in this range, and then going through all the subsegments of that size is not good. Okay, let's ask another question. Yeah, let's ask another question. 1, 2, 1, 3, 2. Here we can have two lengths, 2 and 3, 2 and 3. And let's say if we end our subsegment here, then how many distinct numbers can we get? And 1. But our length has to be in this range. We cannot do a dynamic programming because limits are too much. We cannot create a DP state of which depends on the length and how much of the vector we are choosing, because n is 10 power 5. That is too big for dynamic programming of like two-dimensional dynamic programming. So let's say is still, if you were to ask this, ending here, how many segments can we have where the number of distinct characters is 2, and that is 0 for this. Then for this answer is 1 because we can take this subsegment, and then for this answer is 2 actually. One subsegment would be this and another would be this. So 2, and for this answer would be 1, and for this we can take this 1, and the total answer turns out to be 5, which actually is the correct answer. But how do we fill an array like this? If I know that for each, okay, if we calculate for each index, how much further do I have to go to get at least k distinct numbers? For this, it would be this range. And how much further can I go once I have this many distinct numbers? That would be this much. Right. And I think we can use a stack here. And we would have to create two vectors. One is how much we need to go, and one would be how much further we can go, not messing up this condition. I think we can use a stack here. Yes, stack. Yes, okay. I think we can use a stack here. Shit, yes, we can use a stack here. So when we have 1, 2, 1, 3, 2, when we see 1, and what we are going to store is a couple of things. First of all, the number of distinct elements, not just a stack. No, no, no. A stack, 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 stack. How many distinct numbers we have seen till this point? No, 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 no. How do we decide the current number is a distinct number which hasn't been seen before? For this one, if you want k equals to 2, two distinct numbers, we have to go at least a length of 2, and the maximum we can go is a length of 3. And then when we are at 2 to the right, we can go once, but not any further. And for this one, we can go just once. And for this 3 also, we can just go once. And here the answer is 5. Yeah. 5. One is this range, one is this range, one is this range, one is this range, and this range. 5. Think we can use some sort of stack. Maybe no, not exactly. Whenever we see a number, what do we have to do, and what are the invariances which we have to keep in our stack? In our stack, the earlier we saw a number, right? Okay, if I see 2 and then I see 1, this seeing this one changes the number of distinct things seen by this 2, but not by this 1. And if I were to see a 2 again, then this 2 does not change the distinct numbers for neither 1 and 2. Okay, okay. 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 So when we are here, 1, 2, 1, 3, 2 in our stack, we will add 1 to our stack. Okay. And also the index, let's say this is a pseudocode. And then we see 2. And we can have k equal to 2 at max. So we can add this 2. Okay. We can add this 2. That is very nice. Okay, so size of our stack will not exceed k because we cannot have more than 2 elements. Okay, more than k elements, more than k distinct elements. And whenever the size of our stack is exactly k, then we will do some magic. Okay, so we added 1, then we saw 2, which is different. Then we added 2 to our stack. And we also have their indices. Okay, now the size is 2. We need to see how many subsegments there are and the number of subsegments. This is one subsegment. Okay, so let's say we add 1 to our answer, which is correct, which is this. And then we saw 1, and we can keep a set, a different set. Yes, we can keep a different set. We can keep a different set. Yes, because we also need the order and we also need how many elements we have seen till now. Okay. In our set, we have 1 and 2, and we see a new number which is 1. So we check it. Yes, it is already in the stack. So we can increase the answer by 1. But also we will keep track of the length of the current thing. And if there are k elements in our stack, the size of our stack is k, and the length is in this range. There are like length given to us, LC, let's say current length is in this range, L to R, then we will add 1 to our answer, and the current length would at this point become 3, and we won't add anything here. Okay, and shit, we don't need a stack, we need a queue actually, because we need to remove 1. Then, yeah, makes sense. We would have to remove 1. Okay, then we go to 3. Uh-huh. But, but, shit. Not just this, shed. We added this range to our answer. We added this to our answer, but we also could have added this to our answer. And that makes sense. That makes sense. If in our, let's say this is our queue, and there are some numbers A, B, C, D, and we see B again. And the size, let's say, already is equal to K, 4. Then let's say our sequence is like A, B, C, D, B. Then this is a valid answer. This is not a valid answer, but this is a valid answer. Okay, so this is not a valid answer. So this B extends the answer. Let's say we saw C. If we did saw C, if we saw C, then this C is only acting as a repeated element. Yeah, it is only acting as a repeated element for all of these, but not for D. If you were to start a segment from here, that that would be pretty nice. Yep, that would be nice. And in this particular case, we had 1 in our subsegment, then 2, and in our queue, and k was equal to 1. K was equal to 2. We needed two distinct numbers. Then we saw 1. This 1 only acts as a distinct number for all the numbers which are to the right of this one. Uh-huh. Which are to the right of this one. That is true. We are already at 30-minute mark for all the numbers which are to the right of this one. And if we were to add 1 to this thing, we would see, yep, cool. If we were to add 1 to our queue, can we remove this? We can only remove this. Shit. We can say that this one, we can add 1 to our answer whenever we see a element that is repeated and the total length of our queue is equal to 2. Yes, we can do that. But we also need this. We can use 2 pointers. I think we can use 2 pointers here. Not even a stack. 1, 2, 1, 3, 2. Both of our pointers start from here, and this will move forward till we see at least k distinct numbers. So here, now we have seen k distinct numbers, and our answer increases by 1, answer plus 1. And then our right pointer moves to the next number, and here we see, and also we will keep a set of all the numbers which we have seen, and we see we match this one with the set, and we see that we have seen this before. And yes, we have seen this before. We have seen this before. So how much do we add to our answer? We will add 1 to our answer, let's say. Okay, let's say we will add 1 to our answer, and then we move forward one more time, and we see this is a new element, right? This is a new element. And we will move our left pointer to the right, but we cannot just remove 1 because there is 1 still in our range, whatever it is. But also our right pointer has moved forward, and we were not able to like get an answer from for this range. Shit, let's suppose our right pointer did move forward, but let's say virtually it is still there. And while there are still k distinct integers in the left pointer and the right pointer -1 range, both included, then we will keep adding 1 to our answer. And in this range, there are two distinct numbers. So we will add 1 to our range, and we will move our right pointer again to the right, and left pointer again to the right. And our left pointer is now here, and right pointer is here. And now we have k distinct numbers. So we add, which is k equals to 2. We will add 1 to our answer. Now we see another, and also, how do we keep track of which number we see? I think we can keep a set and a multi-set. Yes, set will tell us how many distinct numbers there are, and multi-set will tell us, will help us in seeing how many iterations of that number are. So when we see a number which we have seen before, we will add it to our multiset. We will check it with our set and add it to our multiset. Our multiset would have 1, 1 and 2. And when we saw 3 here, now, which is distinct, which we haven't seen before. So we will start moving our left pointer. And when we move our left pointer, we will see, look at the current element where the left pointer points to, and we will remove that element from our multiset first, then we will see something else, and then we will check, do we still have that number in our multiset? And if we still have, after removing one, if we still have 1 in our multiset, that means k is still intact and we will add 1 to our answer. Cool. Okay. And then we will move on to the next number, 2. We will remove 2 from our multiset. And we'll check, is 2 is still there? No, 2 is not there. So cool. But okay, cool, 2 is not there. So we can remove this. We can remove this 2 from here. And now we can officially move our right pointer to the right. And to remove 2, we have to move our left pointer to the right of 2. And now our left pointer would be here. And we can officially move our right pointer right. And we will add 3 here and 3 here. And the sizes of our set is again 2. And we will add 1 to our answer. And I think this is cool. This is cool. So what are the invariances that we are keeping? What are the things we need? We need a set, a multiset. We need a set of integers, a multiset of integers. Okay. And what are the invariances? Invariances is number of distinct elements between L and R is always is all is always less than or equal to k. Okay, and whenever we see it is equal to k, we will increase our answer by 1. That makes so much sense. Hello, good afternoon. How is everything going? And shit, I saw your, like, I was usually, as usual, I was stalking you, and you gave yesterday's contest and it was very bad for you. But I think there is also a positive. You just have to keep at it and you will get better. Not that you will get better. Yeah, sometimes it is not that you cannot solve a question, but you are not in the right mood to solve the question, or not in the right mental state to be able to solve a question. I guess this is just going to make you stronger with time. And let's do this. I think we can do this. We can do this. 2 pointers, and the time complexity is also not very big. Boilerplate and okay, we have a couple of things, N, K, L, and R. Right. See, in N, K, L, and R. And R is the maximum length which we can have, and K is the minimum length that we need to have. So if the maximum length which we need is smaller than K, then we can write off output 0 and return. Otherwise, otherwise, let's say this is Mn and this is Ms. And Mx, Mn and Mx. Okay. And we will have our left pointer to the left and right pointer also there. and we need int length. Length is initially 1, and distinct, we will need a set, let's call it S, and we will need a multi-set of integers, ms, multi-set, and we need, okay, we have the length, okay, that is cool for int, not int, while r, while r smaller than n, or while L is smaller than n, yeah, that is pretty nice, or while L smaller than n minus k. K is the minimum length that we need, smaller than or equal to. Yeah, if we need a length of 1, then L can be, if we need one distinct number, then L can be this. Yeah, cool. Okay. Okay, now we need to move our right pointer to the right. So if r plus 1 smaller than n, we can move to the right. Hello, B was combinatorics. Yo, hello. I think with these things, we just need experience. Yeah, I joined late for the contest and I was not able to solve C. Yeah, I saw that. You solved the first question is in 12 minutes, I think. And combinatorics, we just need, I think, experience with that. So if we can move our right pointer to the right, then we will see if s dot count, if s dot count, should we haven't even taken the array for int reference x a take into x, and yeah, do we have we seen a r plus 1? If we have seen a r plus 1, then we can easily increase this, and also let's make this long just in case, and answer plus plus, because we are able to extend our range without increasing. And yes, what this means is what we have is starting from the L pointer till the R pointer, is the current range valid? If the current range is valid, then amazing, cool. But yes, we will only increase R if R is smaller than n plus 1, and and R plus 1 is smaller than max, because we cannot have a length greater than mx. And also there is a minimum thing. Shit, we cannot just do this. Now, when we see that we have this new element, which we are going to have, it, yeah, length will increase by 1 for sure. Yeah, length will increase by 1 for sure. And we will add it to our multiset ms dot insert a r plus 1. And do we know if these conditions are true, can we just increase our right limit? I think we can. Monotonic stack. Yes, I did. Yes, I did. If I was able to solve C, then it would have been good. I would have got 4K rank. That would be nice. The rating delta doesn't matter. To be honest, once I am able to solve C consistently in every contest, then I will increase automatically. Yep. Yep. That is a nice mindset to have. Yes. Let's go. The only thing that differentiate pupil, expert, master, GM is the number of questions you are able to solve. Yes. Yeah, I mean, yes, because I think I have solved A questions sometimes faster than a higher rated player, but later on, I just stop after solving two or three, but higher rated players go on solving more questions. So yeah, that is why they are higher rated. The number of questions, len plus plus, okay. And here, when we are here in this condition, we know R does not go outside our range and R does not increase the length too much, and this is not a distinct number. So we can certainly do this, and now, okay, okay. I think at the end, if we check if s dot size equals k, and yes, after whatever we do here, we will make sure that the length, okay, size, we have same distinct numbers, and the length is cool. Length is as it should be. We don't have to keep length as this. We can just do ms dot size, and ms dot size is greater than equal to mn, right? And ms dot size is smaller than equal to mx. Then we can certainly increase answer by 1. Okay, and what are the other conditions that could be? S dot count AR plus 1. This would mean, yes, if we are here, we know we can extend the stack, the right pointer, but right pointer is a new element, and it would be a problem depending on the size of the, depending on how many distinct numbers we have seen. If, not two ifs, if s dot size already equals k, and we have seen one more k element, one more distinct element, then things are going to be a bit messy. But if we have not, then s dot insert a r plus 1. And also here, since we like literally extended r, we can do r plus plus plus. And here also we can do r plus plus. And increasing the answer would be handled here. Cool. This seems like much more development than competitive programming, to be honest. And yes, monotonic stack was pretty good. I did a few questions on lead code related to that. Monotonic stack. Yep, there were a few questions. Yo, these largest, this is the same question which I sent you on the Discord. And car fleet, this is a nice question. This was not that hard. This one was good. This one was, yeah, this one gave me a little bit of problem. This question was nice. Mm, evaluate reverse polish notation. This question was nice, and yeah, that is it. Mm, monotonic stack is a nice thing which we can use. So if this is the case, then we will have to move our left pointer to the right. Okay, we have to move our left pointer to the right. So yeah, cool. While s dot size equals k. Wait, we don't have to do this. Yeah, we can just use the while statement. Yeah, while s dot size equals k, what do we do? We must move our left pointer. So L plus plus, no worries with that. And L plus 1 smaller than R, smaller than or equal to R. we first move this. No shit, we do not. We cannot just first move this. First, we have to remove this element from our multiset. So ms dot shit. But this is going to erase all of the occurrences of this particular element. So how to remove just one occurrence of a element from a multiset C++. And multiset is there a function algorithm to erase just one sample, unicate or duplicate of an element. Huh? Yeah, find the iterator and then remove the number. Okay, so we do know for a fact that the number does exist. So ms dot find which number a l, and then ms dot erase this number. And now if the number still exists, yeah, if ms it equals ms dot find a l. Okay, we did remove it. Yeah, if the number still exists, if it is not equal to ms dot end, the number still exists, then answer plus plus. We have one more range where the number of distinct elements is equal to k. But also, shit, we cannot just increase the answer like this. We have to also check the length, and the length depends on ms. Okay, if the number still exists, and now two things. If ms dot size is greater than equal to the minimum length, it can be, and ms dot, and yes, ms dot size is going to give us the correct length. Yes, it is going to give us the correct length because it has all the elements which we have had. Size less than equal to mx. If the size is within the range, then answer plus plus. Now, since this is then okay, then s dot size didn't change, literally didn't change. But any case, l plus plus would do the job. And yeah, if does not equal to end, then okay. Else, if it is equal to end, that is, we have removed all occurrences of this current element from our multiset. So we can remove this element from our set also. S dot erase al. And in this case, we will exit out of the loop because s dot size would be smaller than k. That is nice. That is nice. That is nice. Okay. Okay. It ms dot erase, we erase this current number. When we get into this loop, we see that the size is too much, and we only get into this number if we see a distinct number. Okay, so when we get out of this loop, either we have two possibilities. Either s dot size is not equal to k anymore, or we cannot increase r further. We cannot increase l further than it is. It is already at the like boundary edge. Okay, if it is, it would be in the case, and l, since r is not updated to the new value, we had this, and originally we had r at some point, l at some point, and then we virtually checked the next element, r next, and we started moving l, and l can come till here. And if we exited because of this condition, that is, l is already here and we want to move it here, this would be the case only when this and this number are distinct and k equals 1. right? Because in this range, we only have one number, and that is like still equal to k. This condition is still true, and this is still true. Yeah. So in case of k equals to 1, in case of k equals to 1, shit, we can handle it separately. We can handle it separately. In case of k equals to 1, answer would be in case of k equals 1, when we just want one distinct numbers and our array is somewhat like this, we have four numbers which are same, equal to each other, and our left pointer was initially here, right pointer was here. We virtually moved our right pointer and checked the next element, and we see that the next element is greater. It is distinct, and if we add this, then k would become equal to 2, and that would like mess up our condition. So we would like to move our, okay, let's say we can move our left pointer to till this point, and that would be nice. That would be nice. Okay, r plus 1, r plus 1, and okay, if r plus 1 and we are here, then when we move our left pointer to this point, we will see that still k equals 1, we will add 1 to our answer, plus 1, and then we will move our left pointer here, we will add 1 to our answer. When we will, then we will move our left pointer here, and we will add 1 to our answer, and then we will move our, but then we will move our left pointer here. We will move our left pointer here, and then we exit. But the problem that I'm seeing is that when our left pointer is here, this element is not added into the stack, into the list. So that does not look good. But I think, yeah, this would work because we are just adding the element here on the next line. So that is nice. Okay, L plus plus and shit, this condition should itself be enough. Yeah, this condition should itself be enough. We will do this, right? So when our L is here on the last element, when our L is here on this element, let's say, we will check, we will remove this from our multiset, and we will see if this element is still in our multiset. It is, and we will increase our answer if the length is within the range. If element is still in our set and length is within the range, we will increase our answer. Else, if the element is gone, then we will remove the element from our set. When we are here at the last element, and we will remove this from our multi-set, then we will remove it from our set, and this condition would become false. Okay, cool. Have we taken care of all the cases? This case, okay, this case, when we can remove, when we can move our right pointer to the right. If we can, if we are going to move our right pointer to the right, we'll see this. Uh, if s dot count a r plus 1, the next element has not been has been seen before. If it has been seen, then insert it into our multiset and move forward. Otherwise, this, and when we add this number to our set, we will also add it to our multiset. Miss dot insert AR. And in this while loop, we make sure that we have moved L as much to the right as we like, as is necessary and not more. Yeah, when this condition is false. When, yeah, when s dot size would be k minus 1, we will exit, right? When s dot size is k minus 1, we can add our new distinct element to our multiset and our set. So that is nice. Else, if we cannot move our left pointer, and also we are increasing our answer here whenever we move our right pointer. Whenever we move our right pointer, we are increasing our answer here, and whenever we move our left pointer, we are increasing our answer here. So that is nice. But if we are here, also, I don't think we will have to check this condition, because we will never make our right pointer go too much further than it can. Sorry, not this condition, but this condition. Yeah, we won't have to check this, but anyways, shit, there is an error. And okay, else if we cannot move our right pointer, this would be the case. We need to move our left pointer to the right, and only once. Yeah, we only have to do this once. Why? Because does not matter. Okay, if this condition was the one which made this whole thing false, then we only have to move our left pointer once so that our right pointer can move one step. But if this condition was true, then we have to go all the way and do this thing. Okay, let's do this. If r plus 1 is equals n, then we have to go all the way and do this thing. Move our right pointer till the end, move our left pointer till the end. And also, after this, we can break. Else, we just need to move our left pointer to the right once. And yeah, auto it ms find in the multiset al, and then ms dot from the multiset erase it. And if we still have the number in our multiset, like ms dot find al is not equal to the end. If it is not, wait, are we making, yeah, we are making sure that we do not exceed the number of distinct elements more than k. Okay, yes, we are doing that. If ms dot find l is still there, is not equal to ms dot end, then we will increase our answer if ms dot size greater than equal to mn, and ms dot size is smaller than equal to mx, then answer plus plus. And this is enough. And also, in any case, whatever the case, L plus plus. If the element is gone, then we will remove it from our set. S dot erase AL. But if it is not gone, we will just remove it from our multiset. That is nice. That is nice. And okay, is there anything else? Yes, let's check this whole thing. If R is like at the right boundary, then while we can move the left pointer and still have something. We will keep increasing our answer while we can. Else, I think else we can break, else we can break, else we can break, else we can break. And this loop is always incrementing L by 1, so that is a nice thing. And hopefully this thing works. If this breaks, that would be very sad. If this breaks, that would be very sad. Shit. Okay, if R is smaller than K in line 13, that is a nice question. That should be emits out of bounds, out of bounds, out of bounds, out of bounds. I think it is in this case out of bounds when we are blindly moving L. We cannot move L fast than N. Okay, still out of bounds. Shit. Okay. Uh, L and R. What do we see? We see a bunch of numbers. We see 0. 0 is the answer for the first case. Shit. Why is 0 the answer for the first case? That is not the answer for the first case. Yeah, 0 seems to be the answer. And we never went past anything here. K was equal to 1. L was equal to 1. M was equal to 1. Answer should be 5. Yes, answer for that should be 5. Let me turn off the fan for a minute. Yeah, we got this. We can do this. S dot insert. So in the first case, when we have a bunch of ones, in the first case, when n equals 1 and k equals 1, r equals 1, l equals 1, and our number, our vector is also just ones, a bunch of ones. In this case, the answer is 1, and we are seeing that L and R exits here, and which is shit, this condition is wrong. This does not even make sense. Yeah, this does not even make sense. Length would be L R minus L plus 1. This is the current length. R minus L plus 1. Yeah, this is the current length. And okay, if k equals 1, then answer plus plus. Answer will be 1. Yeah, we'll make sure. And this is the current length. Shit, we can use ms dot size. Ms dot size plus 1 because we want to add one more thing. This thing is smaller than or equal to mx. And here has to be smaller. Yeah, let's see. We have one test case where n is 1, k is 1, l is 1, r is 1, and the numbers are 1. Shit, I messed up. I messed up. One test case where n is 5, k is 1, l is 1, r is 1. Yeah, and then the numbers 1, 2, 3, 4, 5. Answer is 5, which is correct. Answer is 5. Answer is 5. Okay, out of bounds. Okay, out of bounds. We saw the answer 1. Why did we see? Wait, 1. Why? Should we only have one number? So, okay, answer 1 is okay. Answer 1 is okay. But then we messed up. Some out of bounds things happened in this case. In wait, what? Okay, this 5 makes sense. This 5 is the vector. Okay, and this is the next test case for which we got an error. Okay, okay, let's debug this. L, R, and L. For the second test case, we have this one test case, and which is the second one. Okay, we went, okay, our left pointer and right pointer were here. Then we moved our right pointer here, which is nice. Then we moved our right pointer again, which is nice, okay. Length is also good, and number of distinct numbers is also good. Then we moved our left pointer once. Our left pointer came here, but our right pointer also came here, which is not very good, which is wrong, literally, which is, yeah, it is wrong. It is wrong. It is wrong. It shouldn't have happened. Our left pointer should have become 2 after this. So something wrong. Okay, we didn't even go there. We went here, and that makes sense. No, no, no. Yes, that makes sense. That makes sense. Okay, that makes sense. Answer should have also increased. I would, no, no, no. We have one test case, and these are the numbers, and answer was 0, 0. Answer became 1. It became 2 when we were in 1 to 3 range. But nope, L and R cannot be equal to this because K is too much in this range. K is 3, but we cannot have more than 2 distinct numbers. So that is wrong. That is wrong. And who increased R, L, and R? I think this guy is to blame. No, I think this is the thing which messed up. Are you doing R plus plus here anywhere? No. We must have gone into this condition and we found the 1 here. Yes, we found the 1 here. MS dot size. MS must have been equal to 3, and 3 plus 1 would be smaller than, would be greater than max. So we went into this else statement, and here R was not at the boundary, so we went into this else statement and we found 1 in MS and we erased that, and we saw that that one still exists in our answer. But okay, we do later increase L by 1. That is nice, but we do not increase R, which is what we have to do. which is what we have to do. This is what we have to do. Okay. We can share. We do not. We cannot do this. Okay, this is bad. This is not good. So wait a minute. Shit. I'll be right back in a minute. What's up? Hello. Everything is amazing. How are you? Yo, I'm back. Okay. And we are trying to do this question. And it has taken more than 1 hour, and we are still unable to do this. But I think we can do this. This is nice. This is nice. It feels nice to spend more time on this question. Okay. We are moving our R pointer, and we are also moving our left pointer. And so we removed incrementing our answer at the end of each while loop. So that was there when we were increasing, and that was there when we were that took was taking care of whenever we were increasing our right pointer to the right, and all the conditions were met. There are only three conditions. First, number of distinct elements is k, and the length which we are considering is between L and R. So whenever we move our right pointer, if length, okay, let's check if s dot size equals k. That is one condition, and ms dot size is greater than equal to mn, and ms dot size is smaller than equal to mx. In that case, answer plus plus. Answer increases by 1. So why do we do out of bounds? How does out of bounds even like happen? Out of bounds cannot happen here because we only come here if we can come here. R plus 1 is smaller than L. So that is not very bad. And okay, this is also nice. Yeah, while we can move our L pointer to the right, we do move our L pointer to the right. So this is also nice. And yeah, our L pointer never becomes too big. So what is causing the out of bounds error? One test case with these few elements, uh, this much things. Answer is equal to 0. True. When we first began, let's keep track of how these values change at the end of a loop. That is a big value. One test case and copy. Okay, so in the first iteration, our right pointer moved to the right. Amazing, but we didn't increase the answer, which is wrong. Okay, so that is a mistake. We should have increased our answer by 1. This thing would have been true. S dot size. Nope. S dot size was not equal to this. Uh-huh. we do move our right pointer to the right, and we do insert this new element AR. Okay, so shit, this thing should have increased. Why has it not? Cout s dot size space ms dot size end line, of course, yes. One test case, which is this. Okay, and yes, the s dot size and ms dot size is still 1, even though we are increasing the right pointer. So that is okay, that is completely wrong. That is wrong. So yeah, this condition is true. Okay, and s dot count er plus 1 ms dot shit s dot insert a0 and ms dot insert a0. Okay, that is nice. One test case, and this is the input. Answer comes out to be 5, which is actually the correct answer. Okay. Okay, we are getting a wrong answer here, and we are getting a wrong answer here. Here we are getting a higher value, here we are getting a lower value. But everywhere else, the answer is correct, which is pretty nice. Yo, Ayush. Which machine do you prefer to use to learn AI? Which machine? I would prefer a machine with a better GPU, maybe Blackwell or something in NVIDIA 5000 series would be pretty nice. 500 or 5000, whatever the terminology is, and that would be pretty nice. But unfortunately, my laptop has only 2 GPU cores, which is pathetic. Mac only has like 2 GPU cores, M1. That is crazy. We are getting wrong answer here, right? Here, our program is giving answer that is a little big. Okay, let's simulate. We have one test case where this is the input for the last one. Okay, we move our right pointer to the right once. We move our right pointer to the right once. That is nice. And yes, we have two distinct numbers. That is nice. Then we move our right pointer to the right again, 2. That is nice. And in the multiset, the length is 3, but we have only two distinct numbers. That is also nice. And when we try to move our right pointer to the right, I think we cannot. Yes, we cannot. So we move our left pointer to the right. Right. But we increased our answer by 1 here, which is not very nice. We can only do this, yes, if s dot size equals k. One test case, and these are the numbers, and the answer turns out to be 5, which is correct. Okay, and the answer turns out to be 5, which is correct. Now, this one is the only one that is giving a wrong answer. Let's check this. One test case where this is the input, and answer turns out to be 7, which is certainly not correct. One test case, this is the input. Okay, okay. We have this many elements. the minimum size can be 1, and we need to have 3 distinct numbers. Okay, our right pointer moves 1, our right pointer moves twice, and our answer becomes 1 at the end. Okay, then we can move our right pointer once, which is nice, and we do actually move our right pointer, and yes, we have 2 distinct numbers. Yes, and answer did become equal to 2. That is nice. And then we did increase our right pointer by 1 again, and answer became equal to 3, which is nice. And then we did move our right pointer to the right, and that was nice. And then, yeah, answer increased, and it became 7. It Answer became 7. Wait, what are the things here? This is one segment. 1, 2, 3, 4. Cool. And answer was equal to 4 when our limits were 0 and 5. Right, and then we started moving our left pointer to the right, and the new, this would be one answer, this would be another answer. Shit, that makes so much sense. That makes so much sense. We are not considering this segment and this segment, but the answer is still off by 1. These 4 we are adding here, which is right, and then we should be adding 4 again to our answer, and this should have been 8. And there is a logical mistake. We are not considering this and this subsegment. Okay, at the end, while start size equals k, and L plus 1 is smaller than this. Okay, remove this element, and yes, remove this element and see if it is still there. If it is, then do this, right? Cool. And if it is gone, then erase it from our set and do L plus plus. Compile, we have one test case with these numbers. Okay, we had 4, and before this our left pointer was here. Then we removed 1, and we saw that we have not removed anything new. So yeah, cool. Right, so we increased our answer by 1. Then we removed 2, and we increased our answer by 1 more. So in total we increased our answer by 2. Then we removed this, and we increased our answer by 3, right? That makes sense. So we added this to our range, we added this, and we added this. So all the ranges that we have added, this is 1, 2, 3, 4, and 5, 6, 7, which is exactly what we have done. But there are other ranges too. There is this thing, there is this. Okay, this we have added. There is this, there is this. Shit, yep, there is this, and 1, 2, and 3. These 3 ranges were not added, and that is why answer is like off by 3. I think we can look at the editorial now. Thinking about the Mac Pro M4 with its 24 GBs of 24 GBs of M4 would be too much, and in M4 Pro would be too much unless you are doing heavy rendering. I don't think you would be able to exhaust 24 gigs of memory. 24 gigs is just too much. Yeah, literally 24 gigs is too much. You wouldn't need 24 gigs. 24 gigs is a lot. My laptop has 8 gigs of memory and it is working completely fine. Yeah, I rarely like have problems because I have 8 gigs. So 16 is enough. It depends on what you are doing. I just code and stream, and this is not a problem. 24 gigs. Yeah, memory is not a problem. I would say if you are going to do video editing, then 16 is fine. You can go with 16, but over 16, no one needs memory more than 16 gigs unless you are some crazy person who is doing AI ML stuff. And I think even with AI ML, shit, if you are literally training models or running AI natively, then you might need more gigs of memory. But in M4, you do not have a lot of GPU power, so you won't be able to exhaust this much memory. If you actually want to run AI models natively, then you need a better GPU, which is not a Apple thing. Apple does not give you a good GPU. So, nope, I haven't given yesterday's contest. I will give the contest today virtually later. Yep, Swift YouTube. So, and we can read the editorial now after spending 1 hour. And why? Because here we are able to add this range to our answer. We are able to add this. We are unable to add this range. When our right pointer is here, how much can we move our left pointer and still have distinct numbers exactly equal to k? That is crazy. 2 weeks ago, in Division 3, question number E. Okay, that seems small enough. Let's fix the left border I. Yes, let's fix the left border I. So they are fixing the left border and they are seeing how much they can move the right border. Okay. When we had our left border fixed here and we saw that we were able to move our right border till here. And what was the minimum amount which was needed for our right border? It was this. So we can move our right border in this range. Okay, our right border is nice in this range. And I think so we add, yeah, we add 1, 2, 3 to our answer. And but when we are moving our right border to the right, when we are moving our right border to the right, shit. When we are moving our right border to the right, I think instead of adding just 1, we should add for all of these right borders which are there, right? In our in this algorithm, we fix our left border and we get a range of right borders which have this left border as a valid border. Then when we move our left border, how can we see how many of these right borders have this left border also as a valid border? And I think all of them should And okay, so when we were moving our left border, our right border, we added 3 to our answer for this thing, and this thing. And we will say the buffer in which the right border is valid is 3. Okay, then we add 1, then we move 1, and we see that the number of distinct numbers is still k. Then we will add 3 to our answer because this is 3. And then we will move again and we will add 3 to our answer because this is still valid. And we will move again and we will add shit, no. Shit, this also depends on the wait, this is totally a different question. Yeah, this is the one we were messing up with. So here we saw that this much this is the right borders for which this left border is valid. So let's say right buffer is 3 and our answer is currently 1. Okay, this is the buffer. Our right border became correct. Starting from here till here, our right border is valid. Then we will start moving our left border. We'll move our left border here and we will add 3 to our answer, let's say. And then we move our right border, left border here again. And ah, no, that is not going to work. Let's fix the left border. Let the valid right border j greater than I such that this has exactly k elements. And yep, yep, length is also okay. Maintain two sliding windows. Two sliding windows. X. So shit, this is using multiple concepts, two pointers, two sliding windows. X, the minimum right border such that has exactly key elements, and the maximum right index such that this has exactly key elements. All valid right endpoints lie in this range. Yes. Intersect with the length constraints this. The number of good subarrays at I. The number of good subarrays at I. How is I changing? I all valid right points are in this range. This is the smallest right point which is valid, and this is the largest right point which is valid. Okay, intersect with the length. So all the valid right points are this much. Intersect with the length constraint this. That is okay. If we are going to move I to the right, I is some number, then this is going to be the one index 1, index 2, index 3, 4. Okay, cool. And this R is wait, shit. This this R, which R is this? Is this the minimum R or the maximum R, X or Y? That is crazy. Shit. The number of good subarrays starting at I is this is now feeling a bit overwhelming. Add this to our answer, then move I forward and update the frequency contours. Each element is processed once by 2 pointers with coordinate compression. The total time is this. Okay, these questions are more difficult than the normal CP31 1500 rated questions. Shit. These are more difficult than the normal CP31 questions. And I thought Yes, yesterday also I was facing difficulty in solving these questions, and I thought maybe if I just push myself and do not make excuses, I would be like, I might become really good. But I guess I have to get my basics right. Yeah, because yeah, we cannot move forward like this. This is bad strategically. I have to think that there are 3 months remaining, and not just that, also the fact, I mean, at this point, I think I can say that in a year, I will definitely reach 2000 in a year. But I want to gain as much rating as I can by the end of this year, because next year I will also be doing a lot of different other things. So so what should be the strategy? Strategy should be to move myself forward as much as I can in the next 3 months till the end of this year, but also do not push my extend myself too much so that I just stop doing this at all, because this is not good. This is not good. This is just too much resistance in doing even a single question. This is too much resistance. This is too much time to be given to a single question. So I guess fall back, but fall back to which rating questions, or what should be the plan? Okay, let's strategize and stalk some people. There is someone that I always stalk, Cry, and this guy has 2000 rating, so that is nice. And this person has solved 133 hair problems here, and this person has been at this, well, this is 4 years. So okay, so this person has been here for 4 years, and this person reached pupil. Okay, let's go there. No, here in a few months, July, August, September, in 2 months, say. And then this person reached specialist in 1 year. Okay, and then this person reached expert in shit in 1 month. After reaching specialist, this person reached expert in 1 month, and that was because this guy gave 1 year in, I guess, reading about things and getting better at things. So that is nice. Shit, we can do this. That is crazy. But we can do this. Shit, that is crazy. Okay, so what is the strategy? The strategy would be to get really good with these questions. I think in 1200 to 1300 rating, there are just a lot of basic concepts which are going to be used in all of the other questions that come up later. Yeah, and also I'm on the side, I'm doing this neat code IO thing. Yeah, that should be nice. So let's this does feel like uh, a hit on the ego, because currently my rating is higher and I'm solving mm, questions which are below my rating. This does feel like a hit to my ego, but this is necessary, I guess. Because why? Because this is just too much resistance. Yeah, this is too much resistance. So I should keep my goal achievable and also higher. And it should be, let's solve 1300 rated questions, or at least let's solve 1400 rated questions on the stream. Yeah, shit, I was trying to do this one and I messed up this one quite a lot. Let's do this one. And this one is crazy. This is suffix of GCD, and this is prefix for GCD. And we have to see if a valid array exists which would give this prefix and this suffix when we are calculating GCD. And This one is 1400 rated, and this is tough. This is tough. This is a good question. Extension, yo. There are a few extensions in this one. CF Analytics and Code Forces Helper, and this one Carrot, to see how much my rating would change during a contest, so that I do not have to wait mm, for the results after the contest. I can see during the contest how much my rating would change. Yeah, let's do this one, and there are some things for this. Vector int p size n and s size n for int reference x n p c in x and f e s. Okay, and okay, the p vector and the s vector have to be consistent with themselves. If n equals 0, then C out, then we have to see P and S have to be exactly equal to each other. If n equals 1, so if P 0 equals S 0 question mark, then yes, otherwise no. A new line and return if n is greater than 1. Then we have to see that P is consistent with itself and S is also consistent with itself. That would be the case for int I equals 0, I less than n, I plus plus, and bool run equals or true, or let's say okay equals true. And what we want is pi if there is a remainder when we divide pi by the next number, which is pi plus 1. If there is a remainder, then this is wrong. Then okay equals false and break. And also we have to check that S vector is also sufficient, and we have to check that the next number is always divisible by the current number, which would be Si plus 1 divisible by the current number. That's fine. If this gives a remainder, then okay equals false, and this checks their inner consistency within the P and S vector. Now we have to check, do they make sense together? And before we do that, yo, hello, I have to go to the washroom like right now. I'll be right back in a minute. Yo, I'm totally back. And how is everything going on? Okay. We have checked that these two numbers are consistent. These two vectors are consistent within themselves, S and P. Now, if still okay, and at the end we will just check if okay, then yes, otherwise, if not okay, then no with a new line. So if it's still okay, then we will check if they are consistent within themselves. And yes, one more thing, their GCD of the whole vectors should be equal. That is, if P0, P dot back, which is the GCD of the whole vector, is not equal to S0, which is the GCD of the whole vector, then okay equals false. And break does not make sense, but yeah. Else we will have to check more things. Else we will have to see, since what do we have? We have that we have two vectors, prefix and suffix, for any element at index I. Here, this number pi is going to be the GCD of all of these numbers, and here Si is going to be the GCD of all of these numbers. Okay, so whatever this number is and whatever this number is, their LCM is going to be at least, let's say AI is the actual value here in the array whose prefix and suffix these are. If AI is the actual value, then we know at least both of these numbers Pi and Si are factors of this number AI, Pi and Si, and the minimum value for AI is going to be LCM of these two values, LCM Pi and Si. Like, yeah, we know for sure that whatever this number is, LCM of Pi and Si, that is a factor of AI. And we also know for sure that this number onto the left, Pi minus 1 divided by Pi, whatever number we get here, that number is only a factor of Pi minus 1, the number here, but not a factor of AI. How can we say that? Because if it was a factor of AI, that number would also be here at this place, but it is not. So it is not a factor. We can call this X, and also we know Si plus 1 divided by Si, whatever this number is, this is also not a factor of this number of AI. And if we take LCM of these two numbers, LCM, yeah, LCM of X and Y, we know this number is not a factor of AI, and we know that this number is a factor of AI. So these two should have a GCD of 1. If they don't, then then answer is not there. Hello, good morning. How is everything? And this question seems complicated, and still this is just a 1400 rated question. Questions are getting more difficult. Let's implement this. We have done everything before this, but this is the only thing that is left to be implemented. And yep, did you see that, watch that Primeagen video? That this is the year for Linux, and if everyone starts using Linux, that would be pretty cool. You know, everyone having their own LFS implementation, that would be actually pretty cool. But you can use Omarchy if you don't want to implement LFS. But LFS is still crazy. Literally one of the craziest things any human being can achieve. LFS. Shit. Linux from scratch. Okay, else now we have to check this thing. And what are the variables that we will be needing? We will need X, we will need Y, and calculating LCM. How do we calculate LCM? We can calculate LCM by multiplying these two numbers with each other and then dividing them by their GCD. But at every I, we would be calculating a GCD here and we would be calculating a GCD here. And what is the time complexity for GCD C++? I think that it is quite a lot. Log. It is log. Log. Okay, doable. That is still kind of doable. Log is still doable. AI is at max 10 power 10 power 9, and also we can reduce these numbers by dividing all of them by the total GCD, because this number is anyway the factor of everything. So yeah, we can just do that. Yeah, okay. Let's now transform. Shit, there is a function. There is a function for transforming. How to apply for passport? No, how to transform a vector in C++ in place, so that we can transform, use the transform function, begin to end, and my vector from begin to end, from begin. Okay, apply the transform in place and cool. Yes, let's do transform. Transform p dot begin, p dot end, and p dot begin. And what is the function? The function is also, let's say, int g is p dot back, which is the total GCD, and I. Wait, and we have to return I, or what do we have to do? We have to return the number. Return I divided by G. Okay, and we will do the same thing for P, for S. Okay, we have transformed P and S now, but we have to check. I don't think we have to check the first and the last element. We do have to check the first and the last element, and we can check them separately here in the prefix vector at like index 0, whatever that element it is, that is literally AI, because we are not taking GCD of AI with anything. So what we have to see is this number is a factor of whatever the first number is in S, and then here this is the GCD of the whole vector. And yeah, this number here at the last should be a factor of this number, and also this number should be a factor of this number, but not a factor of this number. Shit, okay. We will check the first and the last element separately. So for the first element, if p if p 0, the first element, gives remainder when divided by s 0, or GCD of this number and whatever the second last number divided by this number. Yeah, second last number divided by this number. GCD cannot exceed this number. Or we can say GCD of this number and this number has to be exactly equal to this number here. Okay. Or GCD of P0, comma S1 is not equal to S0. In both of these cases, we are not okay. Okay equals false, and we we don't have to break. Else if we will now check the last number, and yep, here is the last number. This number has to be divisible by this, first of all. And second is GCD of this number and the second last number here has to be exactly equal to this number. That is nice. Oh, you can use lambda capture as well, right? Yes, we can use lambda capture, but we don't need to capture anything here. We just need to change the element which is here. We use capture when we want to use some external variable which we are not providing here. But that is not the case here. Here it is fine. Can we set up Vim for CP in Windows? I think there should be a way using PowerShell, and if Eva Eclipse is here, he might be able to help you because he has read the Linux Bible. He knows a lot of things and he has a very nice keyboard. He can also type very fast. So yeah, that is pretty nice. But yeah, and you should be able to, I think, yeah, you can do that. Set up. Got messed up. Shit, this is the wrong. Close ghosty. Open ghosty here. Shit. Mulholland Drive. This is a movie, and yeah, David Lynch is a different man, the director of this movie. Tmux is still running. Tmux, we just have to attach. TCP, it's still running. And N, what was the name of the question? E, it was a question E. Knowledge of ancients, sponsor of your problem. Nope, knowledge of the ancients is the one. E, nope, shit. Where were we in solving the question? GCD lucky, unlucky. Shit, did it not get stored? Wait, it is here. It is here. Else, okay, and yes, can we use Vim in PowerShell? I think we can use Vim in PowerShell. Yeah, yeah, Choco. Choco is a package manager for Windows. Shit, you can use Choco and install Vim. VS Code setup. Vim seems to be cool. Yes, it is cool. It is cool. You should use Vim and then even flex on people that you use Vim. I've solved this problem in GCD and Lucky now. I remember, bro. That's cool. I don't know. Was this also very difficult for you? This problem seems pretty difficult. No, there are just a lot of variables. And variables in the sense you have to check quite a few things in this. And yes, when you use Vim, you can flex on people. And when you use Emacs, you can do crazy stuff like this. Yeah, you can flex on people. That is amazing. And you can bring out, look at this place. There is nothing between the main function and this upper function. And if we do, now there is a like magic code appeared here. If you use Vim, you can do amazing things like that. It's okay. Here we have to check the second condition, which would be the last element is also consistent. Which is this? This element has to be divisible by this, and GCD of this and this is this. Okay, GC last element in S. So S dot back when divided with P dot back does not give any remainder. Okay, if it gives a remainder, or GCD of S dot back and P bracket n minus 2 second last element in P If this is not equal to P dot bas, then okay equals false, and yeah, else now we have to iterate for int I equals 1, I less than n minus 1, I plus plus. So yeah, it is. Bro, there is an easy approach to this. I will share once you have solved it. Okay, there is a easy approach. That would be nice. Now we have to check in my approach if each element is individually satisfying everything or not. And for that, we have this thing. You have to calculate. And yes, I did read the editorial for this. And yeah, I just read the editorial, but I didn't implement the solution. Now I am implementing the solution. So this is what was said in the editorial. Use these numbers. And now we will have two numbers. And let's also write a function which will give us the LCM. Do we have a LCM function? LCM in C++. Okay, sure. There is a LCM function in C++. That is nice. We can use that. We don't have to write our own. Okay. LCM of NF, let's say NF non-factors is the LCM of the previous element divided by the current element in prefix I minus 1 divided by prefix of I, LCM of this number and the next element in the suffix divided by the current element. Yes, the next element in the suffix would be Si plus 1 divided by Si. This is non-factor, and factor would be LCM of Pi and Si, and their shit, their GCD should be equal to 1, right? Their GCD should be equal to 1. Their GCD should be equal to 1. If GCD of factor and non-factor is not equal to 1, then okay equals false and fail. But I still have a feeling that this will just break. Yes. Uh, should that is crazy. Where did I do that? Line 20. Yes, that is kind of crazy. Now G is not captured. Shit. You were saying we can use capture. Shit. We can use, yeah, we have to use lambda capture because we need G, which is here. This is a variable which is outside of this transform function, and we do need that variable inside here. We can use it. Now we can use it either as a reference like this, or we can use it as a copy. And what would be the copy syntax? I think for copy we just pass in G. Yeah, for copy we just pass in G, and if you want to use it as a reference, we pass in AND. Wrong answer is better than error. Okay, just one test case is giving us headache. Why? Why is this wrong at which point? Let's see. Let's see. See out high. Of course, that is how we debug. High here, high here, and then And here, okay, if we see just one high, yeah, we will always see one high. If we see one high, then yeah, let's see. Okay, line number 35. Hmm. Shit. Compile. We have just one test case, which is first one, this one. Okay. Hi, hi, hi. And then no. Okay. So we are getting kicked out here. This condition is false. Is this like logically wrong? Can you share your profile? I will add you. Yo, yo, we can be friends. This is my profile. And yes, my rating is like non-deserving. It is higher than it should be. And okay. So we are exiting here. And okay, here the logic is, and if these this number is not a factor of the current number. Okay, let's think about this in a different light. Let's remove this, and a factor of not this but pi, yeah, pi, say pi minus 1, GCD of pi minus 1, and f is like at least the value for this number. If this is not, yes, if this is not equal to pi, or we have GCD, we will check for the S thing, S plus 1, which is a bigger number, S plus 1, GCD of F and S plus 1 has to be equal, or if it is not equal to SI, then that is messed up. Okay, we can remove the high. Not this. Okay. Okay, that does work. That does work. That is nice. Higher than me at least. Bro, but yeah. Shit. But this is not enough. I mean, not that this is not enough. I feel like my rating is higher than it should be, because this is a 1400 rated question and I'm facing more difficulty than a 1400 genuine person should be facing. Not that I cheated or anything, but I guess the problems in the contests were easier. Like mm, my rating in the last contest increased just by 21. Mm, so yeah. But yeah, today I will give a virtual contest, and if I get a high rank, that would reignite my confidence a little bit. Okay, let's see this, and hopefully this works. Hopefully this works. Bro, let's stalk him. Let's stalk him. Shh. That is crazy. Is this overflow or anything? No, why would it even overflow? Bro, shit. Bro has been at it for a while. 600 questions, that is a lot of questions. Greedy. Maths questions, implementation questions. That is nice. A nice curve right there. Okay, I removed it. Why are you hanging? Shit, bro is hanging. Wait, okay, I thought that's wait, why was my face like into the camera? Okay, this is wrong. This is wrong. This is wrong. And what was the simpler thing that you were saying? And shit, sorry for looking at your profile on stream. But yes, what was the simpler method that you were saying? An easier approach. I would like to know. I can solve like 13 and 14 during practice, but I struggle during contest. And I think this happens because we are not used to solving questions under stress. Right now, I'm very relaxed while solving this question, but this would not be the mental state while giving a contest. During a contest, things would be much different. Yes, a bunch of conditions. But I think I have checked all of those conditions here. Wait, and what even is the wrong answer? Like, did I say no when I was supposed to say yes? Or opposite? Shit. This is a shit. This is someone's hack. This is someone's hack. This is literally someone's hack. My output was no, but the correct answer is yes. Both of these numbers are prime, I think. Shit, this is literally someone's hack. Someone hacked it. I cannot share solution here. I just resubmitted on my profile. You can check. Okay, I will have to open your profile if that is fine. So submissions. This one, yo, bro got accepted. Okay, that is a lot of boilerplate. Shit. And yes, I don't get what is this? If not online judge, then debug X. And if there is a error, print. Okay, what is this for? I don't get this part. Happy coding. Yes, happy coding. If the current solution is not, if this thing is not getting judged by our online judge, then do some things. You can just simulate the question as it checks. Editorial method. You can just simulate the question as it is and check. Okay, editorial method or something else. This is for online judges. And yes, that is a just a lot of boilerplate. What is this? That is a lot. That is a lot. Shit, you have things for printing a multiset, printing a map, printing a set. And these are just function definitions. Should these okay, I think this part is at least redundant. You are giving function declarations here and then you are defining them right away. So this would not be necessary. And that is a lot of things. That is a lot of things. Okay. Here, debug. Okay. Long n print. Shit. Yes, this is also something we can do. This is also something we can do. This is also something we can do. buffer. We can add a element at the start and at the end so that things are good. Okay, so that we don't have to take care of the first and the last case separately. That is nice. It is my old template. I don't use it anymore. Okay, that is cool. Yes, you should know. No one should use it. So I think I've seen some pro players at very high ratings use this template or like a very bulky template like this. Yo, this I can say. This author and then your name. Did you see this from tourist? From submissions given by tourist because I saw this tourist and has this author tag and I copied it and I also have the author tag in my submissions in the boilerplate. This seemed cool. The camera is still working, that is fine. Fill in the prefix and the suffix and vector long a n plus 2. Then we take in the values. Wait, what? No, we are not taking in the values. We are taking in the LCM, which is, yes, we are shit, and then just simulate and check if it is shit. I love manual debugging. Nowadays, it feels so adrenaline to comment manually debugging. Have you used GDB? GDB is so amazing. I don't know how to use these GDB. Hello. But I've just used LLDB, LLVM debugger, and it is amazing. The amount of freedom it gives you while debugging is like crazy. Yeah. Tourist. I have seen some submissions which have the which have like yeah, that is a lot. If you go to Umnik, his boilerplate is also a lot big, like really big. And he has a dog. Look at this. Wait, he doesn't use include bits. His main function is also very big. Eprint, print error. Shit. Yeah. Okay, that is nice. We can just simulate debugging. Yo, yeah, do working delay. Yes, yes, that is how we debug. That is how we debug, right? Like boo x y and random stuff. Yes, just to know how many print statements we got and the code went till there. Yes, working till there. Yes, that is how we debug. Printf debugging. Hello. Okay, I will not look at your solution. I will try to simulate like what you said here. I have seen this much where you are. Yeah, this is your solution where you make this and then yeah, you are just trying to simulate and seeing if the things work or not. And that is very smart, which is this is much better than what we are doing, what I've been doing here. And N, CNN, and then but you have a buffer. And by buffer I mean you have one extra zero at the start of the prefix and suffix both and one at the end, and that does make sense. That does make sense. If we take the GCD of the last element and the current element, we will get the current element if we are at the first element. That makes sense. Okay, P. And wait, I think the earlier solution which I had written, it was wrong because of this. Maybe. Let's see using a very amazing keybind given to us thanks to this guy right here. They somewhat say bits makes code slower. I mean, this thing is just including a lot of by library code, and the slowness only comes in the compile time, not in the actual running time. Yeah. So no problem in the running time, but compilation takes longer. Just to use it for simplicity. I don't want it complex for zero base indexing. Yes, that is actually pretty cool idea. Instead of handling the first and the last element separately, we can add one buffer of one element and handle everything as, yeah, handle everything normally. That is nice. And this is the wrong one. Hmm. If this number is too big, this number is too big. So let's go all out and change all the int to long, which you can do using uh, in the whole file substitute int with long, but with confirmation and globally. Do you want to change that one? Yes, why not? Wait, shit, this one, yes. This one, yes. No, yes, yes. No, no, no. Cool. Okay, normally still working. And here, this, yes. Shit, okay. Now I guess this will work now. And then I'll apply your thing. Yeah, it was just overflow. Just use long. Yes. Use long completely. Or earlier, shit, now it is long, so it is taking longer, like literally longer. And this would take twice as much as before because GCD and LCM function I think would be slower. But no, it would only take as much time as the number is big. Mm, yeah, that is nice. Now I'll apply your solution of simulating the whole thing. And yes, I think not just me, but a lot of people do this and then just use long and use integer as if they are using long. Is this correct syntax? No, this is not correct syntax. Uh, define int as long. And yes, if you do that, you have to here say 32 int 32. Yeah, if you use this thing here, but if not, then not. Stop the LSP and int n, take in everything. Wait, just wait a minute. I'll be right back. 5 seconds. Not even 5 seconds. Now, the vectors long prefix size n plus 2. I will copy your thing, and suffix is also size n plus 2. And then for int I equals 1, 1 I less than equal to n I plus plus cn pi, and do the same thing for s. We have both the things filled, and we will also create our vector. If we don't, yeah, this fine. Then we will also create our a vector, and a's size would also be n plus 2. Now we'll fill a1 I less than equal to n I plus plus, and that this is actually true because we know pi and si are at least the factors of a, and yes, using ll equals long long. Just typing long long completely as long feels pro. It just feels like as if I'm a pro person, even though I'm not, but it just feels very good. LCM, comma, SI. Share. This should have been the first thing that should be coming to someone's mind. Pi and Si are the factors of this number. Then we can construct the whole A array, and then we can try to see if everything matches in the P and S vector. So now we need to see if Pi vector matches AI vector. And this would be A equals true, and if the GCD of Pi minus 1 and Pi Pi minus 1 and AI is not equal to Pi. If it is not equal to Pi, then okay equals false and break. And I think we can just side by side also check the SI vector. And what do we need to see in SI? The GCD of the next element and AI has to be equal to SI. SI plus 1 and AI if not equal to SI, then okay equals false and break. But shit. And the fact that we have two buffer elements at the start and at the end is just so amazing. So we can just do this and not care about the edge cases. And what if we have only one element? If n equals 1, then at the start we have a 0, at the end we have a 0, and in the middle we have an element, and AI would be the LCM of those two elements. And we will be checking the LCM of the last element, which is 0. If AI should be equal to Pi. Yeah, cool. Yeah, this would still work when n equals 1. So yeah, this is just so amazing. And yeah, this should work. 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 This does work, at least in these cases. And let's also check here if this checks out. Yo. Okay. I clearly messed up somewhere. We create the AI vector, which is long long. And okay, we do know that this number, that was a mistake. That was a mistake, my bad. And yeah, this should be cool. Wait, we don't even have to long, we can just say long A equals this number. And then we can just check A. We don't even need a separate vector. I think, but we also have to see if pi and ai are consistent within themselves. Like every next element in pi should be a factor of the previous element in pi. And will it be like seen here? This does work. This might be correct. This might be correct. Let's see. You can create second P and Q vectors using A and then compare P and Q to old P and Q. Yes, that is also one thing we can do. But P and S, yeah, accepted. Shit, that was fast. And the memory is also very low. And I guess, suppose if you have implemented this approach, then your memory must be higher. It should be higher. Yeah, 200 KB, not that much. Okay, at least now this is not red. Cool. And this is very clean. Shit, this is very clean. This is very clean. Thank you for your um solution. This is very clean. And there are two things in this which I like very much. First of all, here we have two buffer elements at the start and the end so that we do not have to take care of the edge conditions, which is very convenient later on here, which is very, very convenient here. And second is that we are just literally simulating this whole thing. We have our A and we're just checking it out. Shit. This is first principles thinking. We know that the current element A, whatever it must be a factor of Pi and it must be a factor of Si. And let's check. Is this A giving us what we need? And if it is not, then not okay. So this is pretty cool. This is pretty cool. And not even very long. This is not even very long. That is cool. Max count. Let's move on to the next question. Yep, and we will also have the timer this time. Cool. Max, define the max, including value of an array to be the smallest non-negative number present. For example, okay, you are given an array A for A of n elements of non-integer elements for k in this range. Count the number of possible values after removing exactly k values from A. Count the number of possible values from of max after removing exactly k elements. This would just depend on the smallest element. Wait, shit, k is also changing. K is also changing. But still, this would just depend on the smallest element. We can sort A, take in A and sort A. Yes. And yeah, we will be calculating factorials to find out how many ways are there when we want to choose k things out of n things. And in all of those ways, how many ways are shit, in how many choices are we removing the smallest element? And yeah, if the smallest element is not even zero, shit, there could be multiple zeros. Shit, there could be multiple zeros. That is crazy. Yes, zero is the only element that we care about. Zero is literally the only element that we care about. So we just need to count how many zeros there are, and we should be able to figure out our answer depending on the count of zeros. Okay, let's say we have C amount of zeros, because whenever we remove all of these C zeros, then the answer, then the mix is just 0. Wait, what? Possible values of mix. Okay. Mix is either 0. Shit. Okay, this also depends on the bigger elements. This also depends on the bigger elements. Yes. 0, 1, 2, 3, 4. Let's say we have this, and k equals 1. When k equals 1, yeah, when k equals 1, mix would be 4 when we remove this, mix would be 3 when we remove this, mix would be 2 when we remove this, 1 when we remove this, 0 when we remove this. And if k equals 2, mix would not be 4 ever. Mix can be at maximum 3. Okay, we do not need to count in how many ways it is possible, but how it is possible. Okay, shit. Okay, we can just count the number of occurrences of all the numbers, and to have a mix equal to 0, our k should be greater than or equal to the number of times we are seeing 0, and k should be greater than or equal to the number of times we are seeing 1, the number of counts of 1. And yeah, we'll just keep doing that. That is nice. And yes, also if k is greater than the count for any ith element and greater than equal to, then k minus ci, this is the extra elements, and we do not want these extra elements to be removed from anywhere to the left of the current element. Then all the elements to the right, the count of all the elements, left elements, elements on the right which are left, elements on the right which are left, their count should be greater than or equal to this much. And here when k equals 2, and we are here, and we will remove 1, 4, we have 1k left, but there is nothing on the right, so we cannot have this. And that is nice, and I think we should be able to calculate this in a linear pass somehow. This is also a beautiful question. Shit, a beautiful mind. I struggled with it during live and got AC the next day. Yes, this happened. This is this psychology, art of war, Sun Tzu. Okay, let's do this. And we need to have a linear approach to this. What is the value for k equals 1? Yes. A linear approach is what we need. I think we can just sort this, but we can always have, no, we cannot always have 0. We can have 0 when k equals n. Yeah, when k equals n, 0 is the only thing we can have. Yeah, there is only one thing we can have. And instead of this, let's transform this array into something else. First we'll sort this, and yeah, this will become like 0, 1, 1, 2, 2, 3. And let's say we change these to their counts, and we'll have 1, 2, 2, 1. 0 is appearing once, then this, then this, then this. So when k equals 1, yes, and order is required here. When k equals 1, we can have a mix of this and a mix of this. So okay, for any count, what we need for a specific any k, let's say any element, here is ci, k has to be greater than equal to ci, and sum of all of these numbers, sum of all of these numbers, k cannot be greater than this, yeah, this whole sum. So k has to be smaller than or less than this whole suffix sum, si suffix sum till this number. So whenever k increases, the number of possible elements we could choose moves to the left, and also a lot of numbers will become available when k becomes greater than their frequency. When k becomes greater than the frequency, but how do we figure that out? Yeah, this condition is easy to see. We can check this condition. We can make a suffix separately. But this condition, how do we? Okay, maybe, no. Maybe instead of asking for a specific k how many different elements we have, we can ask for any specific element. For how many keys is it a part? Like how many keys can we get this specific element as a mix? But still, shit, this is not good. Well, if 0 is not there in the initial array, then 0 is always the mix. So we will suppose that 0 is there. We will handle separately. If 0 is not there in the vector, then answer for all the keys will be 1. But even if we are able to figure out, I think it would be easier to figure out if this for how many keys this current element is eligible. This current element, as we see, is eligible for all the keys. Smaller than, less than, for all the keys, smaller than or equal to this value, which is just k equals to 1. But then still, shit, this would be n square if you were to go through all the key values and update the answer there. So this thing is not like a graph. Okay, this starts from 1, goes up, goes down, starts from 1, goes up, goes down. Here starts from 1, goes tremendously up, and then comes down, comes down. Here goes up, comes down. Graph. Here answer when k equals 1. When k equals 1, okay, 0, 1, 1, 2, 2, 3. When k equals 1, we can just remove one element. When k equals 2, wait, when k equals 1, actually we can, yes, we can have two mix, this and this. So yeah, let's say this is 2, height 2. And then when k equals 2, we can still have this. We cannot have this. So 1, but we can have a mix of 1 and 2. So this increases by 1. And when k equals 3, we can have 2 as a mix, 1 as a mix, and 0 as a mix. So this is stays same. Yes, this whole thing is tilted. Now it is much better. Okay. And when k equals 4, so here k was equal to 1, then 2, then 3, and for k equals to 0, straight answer is 1 when k equals to 0. When k equals 0, 1, 2, 3. When k equals 4, we can no longer have 2 as a valid thing, but we can have 1, max equal to 1. We can still have max equal to 0. Yeah, nice. This like came down by 1. And when this was 4, when k equals 5, we will be removing at least all of these elements. We can have a max of 1. When equal to 5, so we can have a max of 1 and 2. So still at this range. And when we are removing all of the elements, we can only have 0. So 1. Here k was 5, here k was 6. When we are removing all of the elements. So this went from 1, 2, 3, 3, 2, 2, 1. But is it the correct is it the right thing? This was the thing to last, and not even close. 1, 3. I wrote 1, 2. When k equals 1, how can we have 3 different mx values here? We can remove 0 and have 0 as the mix. Shit, there is also 4. We do not have to delete 4. 4 is like already there. 4 is always the answer. And is there a similar type of problem in CP31 to this? I don't know. I don't think so. Shit, that is what I'm saying. These 1400 rated questions, like nowadays, 1400 rated questions are pretty difficult. And we can take up to 3 seconds in this. That is a lot of time. So for k equal to 0, when we are not removing anything, we already have whatever the mix of the whole thing is there. And when k equals 1, we can remove one element, which could be anything. When k equals 2, we could remove this, this, this. Removing this doesn't even make sense. Removing this is one thing. Yo. Mhm. We cannot ask the question, can we in linear time, wait, 10 power 5, nope, that is too much. Can we in linear time figure out for a specific k what are the possible mix values for k equal to 1. We know the answer is 1 for k equals to 1. For k equals to 0, the answer is 1. For k equals to 1, the answer would depend. For k equals 1, the answer would be how many numbers have frequency equal to 1. That is the answer. How many numbers have a frequency equal to 1? Yes, and we can have their max. Yeah, yeah, we can have their max. And also, if there is at least one number whose frequency is greater than k, then we can remove that number and still have whatever the original mix of the whole vector was. And so for k equals to 0, 1, we can have this, we can have this. They have their frequency either equal to k or greater than k. And there is at least one element whose frequency is greater than k. So we can also have 4 from the start. And shit, sometimes it would be the case if we have something like this 0 1 1 3, and when k equals 1 or whatever the value of k is, we can never have a max equal to 3. So what we can do is, in this case, we can see the current max, and we will only take care of values. Here the current max is 2, the original max is 2. We will never be able to have a value that is higher than the current the original max. So we will just work with these elements. Okay. Shit. Okay, since we know, we want to know, we can put the frequencies of, okay, we can use a map, int to integer map, where mp map I would tell us how many times is I appearing in the vector, and whatever the value is, later we can add these values, put these values into a vector, so that for a given k, at least we will be able to figure out quickly how many values have a frequency which is smaller than or equal to this current k. But also, not just that, we need two things. Not just this, we need two things. Yes, we need two things. Frequency of the ith element and the sum of the all the numbers that are to the right. How many numbers are to the right, which would be n minus I minus 1. We need to remove fi numbers, so k has to be greater than equal to fi, and then we need to remove k minus fi numbers from the right. And on the right, if I is the index of the last appearance of this number, or this number, we can think of it as summation fi plus 1 till fn. Yeah, summation of these numbers. And we can do this in linear pass, because in this vector we can store these numbers as pairs, where the first value will be the frequency and the second value would be the sum of numbers on to the right. And we will sort this vector in ascending order according to the frequency and the number of numbers on the right. I think ascending count of numbers on the right, count of numbers on the right. And what do we need? We need this to be as big as possible. Shit, we need to sort this. That will not work. This is bad. This is bad. This will not work. This will not work. I feel like I've done the problem in some time like this. Shit. I am in class 12th and taking CS. So some advice. Yup. You can start doing programming, and if you want to start doing programming, you can take this thing called CS50. And shit. This is the second time that I'm telling someone about CS50 today, and you can take CS50. CS50 is Introduction to Computer Science, and this is a introductory course by Harvard. This is completely free. All the lectures are on YouTube, and there are also exercises at the end of each lecture. This is 12 weeks long. You can easily take this in 3 months, and yeah, this will just bring you up to pace, and after this you would become pretty good, like good enough to learn things on your own. Yeah, you can take this because they were getting too hard. The 1600 rated problems in CP31 were a bit easier, but here 1500 rated problems, and not even 15 are very hard, but this is a 1400 rated problem and I'm facing difficulty in this. So yeah, newer problems at a rating are more difficult than they were in CP31. So yeah, I had to like lower the rating here. And I'm a third year. Shit. I am also in my third year. I am a third year student and I have done MERN stack from Harkirat, I suppose. As development, I will soon be building a project of it. After that, I'm thinking of starting DSA. Cool, that is pretty cool. Like I tried taking boot.dev. Boot.dev is nice. You can take GitHub course from boot.dev. It is pretty cool. Boot.dev from start to end, but I am facing a big difficulty. What is the difficulty you are facing? Boot.dev is pretty cool. Boot.dev is pretty cool. It also has a DSA section in it, and its course on Git and GitHub is very amazing. Boot.dev, and I think they have a new course on TCP/IP. I don't know. HTTP clients in Go, not in Go. Primeagent has a new course. HTTP protocol in Go. I think this is the one. Is this one by? Yes, this is the one. This is the one by Primeagent. Yeah, this is the one. This is the one. This is pretty cool. In this, from TCP to HTTP, building an HTTP 1.1 server from scratch in Golang. To understand truly HTTP, you should build it yourself. And this is a pretty cool thing. From TCP to HTTP. I also once implemented a HTTP protocol using TCP sockets connections, and I didn't implement the full protocol because that would be crazy, but I implemented enough to get my work done, and it is it was pretty cool. It was pretty cool. And when I moved on from implementing HTTP to HTTPS, the jump is too much because HTTP is nice. HTTP is just a language which two people use or two computers over the internet use to communicate with each other. But when we use HTTPS, you need encryption and you use TLS for encryption, transport layer security, where these two computers, the server and the client, they have to agree on some hashing algorithm which they are going to use, and they have to Yes, first of all, agree on which hashing algorithm they will, or encrypting algorithm they will use, and then what is going to be the key to, so that the client can encrypt the data on his side using the key, and the server can encrypt the data on his side, can decrypt the data and using the key, and then whatever the response is, encrypt the response using the key. It will go back to the client, and the client will decrypt the data using the key. And the way that they agree on which protocol or which hashing algorithm, encrypting algorithm they are going to use, and what is going to be the key, that itself is pretty crazy. And everything which is handling the deciding which is handling encryption and decryption, that is, all of that is like pretty crazy. I had to use for this OpenSSL, because no one can, not no one, but it would be very, very difficult for someone to make TLS from scratch. Best resource, learn X. Okay, you cannot learn this from X environments, but you can learn Golang, but not as a beginner. Unable to figure out a few things in between. Okay, in between. The number of mix depends on the frequency of elements. The frequency of elements, the individual frequencies, how many elements, and also how many elements are on the right of the current element, right? So that you do not remove any element that is smaller than the current element. We can remove single frequency elements to get different mix. We can remove single frequency elements to get a different mix, like elements with some frequency, but not just that. If every element with a frequency lower than equal to k would work, but okay, this is one condition, and the other condition would be wherever the element is appearing, ith element in the A vector. Let's say this is the last appearance of this current number, and this appears a bunch of times in this block. Let's say this block was just 111. So k, first of all, has to be greater than equal to this frequency, and then whatever is left of k, which you must remove, this number k minus fi has to be less than or equal to this, however numbers are on the right. Only then you would be able to remove this current number. Also, the number will keep getting on RAG. Also, there is a new code. Okay, what is RAG? RAG. Let's vibe code all of this. Okay, yes. Next year. Right now, it is just competitive programming, but next year I will be building a lot of things, and it will be very fun. It will be a lot of fun. We will build our own database, like build your own X, build your own database. So the number will keep getting higher as k increases. Okay, a number will keep getting higher as k increases because of this condition, but number will also keep getting lower because of this condition. Yeah, this condition. It will keep getting higher because k is getting higher and higher, and less elements have a frequency. Wait, you have to remove exactly k elements. Yes, exactly k values. So yeah, when k is higher, more k will have a higher value than most of the numbers frequencies, but there will be fewer and fewer numbers left on the right, and you would have to remove like a lot of numbers from the right, and at some point you will not have enough numbers, like 1 2 3 4 here. When k equals 2, even though the frequency of 4 is smaller than k, you cannot have 4 as a mix because you must remove two elements. So when you remove 4, you have to remove one more element and there is no element on to the right. You must remove 3, and since you have removed 3, you cannot have 4 as a mix. You will have 3. That is crazy. Hello. No. I have done backend, but I don't think I have seen the use of HTTP protocols yet. Can you explain how? What do you mean? How do you use backend? Do you use Express for backend, creating APIs? Can you guide me how to get started on DSA? I will be starting it from November. Okay, next year, next month, not year, after I'm done with my project. Okay, okay, there is more than a month. More than a month. If you just want to do DSA, you can go through this sheet, need code sheet, and start solving questions from here, array and hash, and yeah, here's a link for every question on lead code. And if you don't get a question, there is also a solution for each of the questions. So that is nice. A description solution and also a video solution for all the things. There are multiple methods, brute force, different optimized things, and yeah, this should be enough for someone to get good at DSC. Planning to build an express tracker, but not the Excel type. Expense tracker, but not the Excel type. Shit, bro, you can use Excel formulas for this. Okay, shit, I think, yeah, you do have a lot of money. You would need expense tracker. You can build it. That would be nice. And build it in assembly. Someday I will have enough brain cells to understand Linux. You cannot say this after having a physical copy of Linux Bible, right? You do not get to say this. I use Express. Yo. So Express is using protocols under the hood when you create an API, right? A router use this or that, or app dot get. All of that is under the hood using protocols because everything is a protocol on the web. First it increases, then it decreases. Yes, I am an Android dev, so Kotlin. Yeah, so you can do it in Kotlin, and that is cool. Wait, I don't get this. Uh, let's say you have create. I don't know about mobile development, but I have a question. If I write a app, a JavaScript website, then I can just run it on my browser and see what my website is doing. And if you have created a binary for your application, can you just click on it on a mobile and then run it? Is that how it works? I think that is how it works, but is that how it works? The name of the expense tracker. Yes. Okay, shit. So if that is the shit, that is just too much power on your hands. Because if you are creating a website, you need a browser. If you are creating an app which can natively run on your machine, that that is too much power. And can we also do this in iOS? When we create iOS apps, can I just run any app I want? But if I can run any app I want on iOS, then that is like jailbreaking the phone. Yes, I will have to use Swift. Shit, this is actually pretty cool. This is actually pretty cool. I will have to use Swift, but I can run anything I want. That is amazing. That is not jailbreaking, isn't it? Because you can run any program, and yeah, you can run any like shit like this. Like when we run a program here, compile and run. This is literally the same thing. Whatever you want the hardware to do, you can write. You get emulators. Makes sense. We are not directly running on the hardware. We have to go through the operating system layer. Jailbreaking would be more like you have kernel level privileges. If you're doing competitive programming, then you must be doing it with C++, right? Yep, this is C++. Yes, sir. C++, cool language, very complex, more complex than it needs to be to try and test, or you can physically connect your device via data cable to make it a testing device. Hmm, testing divide. Hmm, shit. So, jailbreaking is more like your process, whatever you are running, has kernel level privilege, but this is more like emulating when you are running your app because you have to go through the operating system layer and yeah, okay, you are not running natively. That makes sense. If that is correct, yeah, that makes sense. Hello, friend. Alexander Petronov. Is that a famous person or your actual name? Hello, we are amazing. How are you? And where are you from? Are you from Russia, Ukraine, Kiev? Jailbreak is just making your device vulnerable in the sense that you can do whatever you want with your device. That is nice. You can do whatever you want with your device. That is your actual name. Russian name, I believe. Yes. Bro, nailed it. Could be Russian, Ukrainian also. Vladimir, Alexander, Alexander the Great, Alexander Volkanovsky. Yeah. Bulgaria. And I'm from India. And Bulgaria, you are from around Sofia. Petronov, I remember. Petrov defense. Shit, bros into too much chess. Pet Petrov defense. Petrov. Shit. And shit. Eto Yatin. Eto Jatin. That is Russian. Privyet Eto Jatin. That is the extent of my Russian. Eto. Eto Mark. Um, again, read a little bit of Cyrillic. That is it. But my German is much better than my Russian. And shit. Okay. You're doing a question. Max count. Shit. And this is a 1400 rated question. That is crazy. Shit. This is a 1400 rated question, and this is just too demotivating. I think I should be solving more 12 and 1300 rated questions before moving higher. I actually don't know about the neat code. Thanks for sharing. Yep, that is nice. I'm also trying to get better at competitive program, but I'm still only 8, 10 on code force. Any tips? Okay. Hawk Shit. Shit, I don't know the how to lore. Shit, I don't know the how to lore. And I think okay, getting to 1200, getting to pupil is much more straightforward than other things. You just have to go to code forces and solve questions. Solve questions at 800. You can select a rating range here and you can start solving questions. Yeah, because all things at that rating they are mostly ad hoc and not any organized way. Shit, that is a lot of questions. And yeah, so you just need a lot of practice. And for theory, there is of course the competitive programming competitive programmers handbook by Mr. N.T. Laksonen. And I would say you can read this chapter second, third, fourth, and yeah, these four chapters would be pretty cool. If you go through these chapters, that would be enough to at least get up to pupil. Oh, shit, I'm not into that lore. I just don't know about that lore. DSA these days is just like GE entrance exams. Everyone does it. Few conquer it. That is, should there is a law, there are sociological phenomena, a specific name for this. It is like 1% of musicians make 99% of the music, which is listened, which is like heard by people, or 90% of the music. A must for placement. I mean, if you do competitive programming, then you have much higher chance of getting placement. And competitive programming does not just make you good at competitive programming. If you are good at competitive programming, then you are good at everything in programming. So that is like there is no downside to competitive programming. Like if you are a good developer, you might not be a good competitive programmer. But if you are a good competitive programmer, you would just take 2 to 3 months to get to a like good developing stage. Yeah, things seem easy after competitive programming. And yes, if you conquer it, there is a law. 1%. Shit. 99 memories. Shit, that is something else. Music law. There is a law, or maybe some condition. Make 99% of music social law. Average share of music income. Power law, superstar effect, cumulative advantage, the long tail is what? The 1% rule, maybe. Yeah, whatever. Yeah, but there is a thing. Shit, that is a lot of things. Is a stream lag? Stream is not lagging. That is nice. Yeah, but it is better to do. See the message by so many people just code because they want a job, because they not because they love softwares. Yeah, that is the bad thing with the Indian education system. But yeah, if you do actually love the thing that you are doing, you will do it. Like you will be much better at it if you are not worrying about it. And this is the same thing which happens during a contest. When you are solving questions on your own, you are much more likely to get it right and less likely to get it right in a contest. Yeah, and I think if I cannot solve the question, I should learn the topics that uh, you can use to solve that question and then attempt to solve it again, right? Yes, yes, you should learn the topics, but at like ratings around pupil or lower than pupil, there are not general topics like sorting or binary search or something from which the questions are made. Most questions are ad hoc questions, which you will just get to know the patterns. It is not easy to specifically train for those kind of questions. You just have to get a lot of experience. Not a lot, but you just have to be in the right mindset to solve those questions. Is it true that you see the same names credit a lot of popular songs? Yes, because you can, like, there are literally a lot of musicians, but we don't listen to their songs. We only listen to a handful of musicians. What was the book again for competitive programming? It is your CP handbook. Competitive Programmer's Handbook. And you can just search this thing, this name on Google, and you will get the PDF. Money should not be the motivation. If it is, you are messed up human being. Bro is too harsh. Okay. But I would say money would be the motivation. And if it is the motivation, you are not a bad human being. You are not a messed up human being. But maybe you never knew that it is an option to not prioritize money and use it. And yeah, not prioritize money and prioritize your passion or love or interest. I would say most people don't even know that this is an option where they are not working hard for money, but they are just working hard to get better. I don't think people know that this is an option. And this is the same thing if you go into religious terms, then I would say most people believe in God because they do not know. Okay, getting to a specific proportion of how many people there are in this category is hard, but I would say there are people who believe in God because they do not know that not believing in God is also an option, because that is all they have known. And this is the same thing which happens with terrorists. They don't know there is something outside this thing, and whatever they are believing in, it is just one of the things in which they could be believing in. Yeah, so you are not a messed up human being if money is your motivation. Maybe you just don't know. You can have other motivations than money. You cannot generalize. Yes. If it doesn't work at some point, then you have to move on to that life. That is why I left CP, competitive programming. I wasn't enjoying it. I would say I also don't enjoy CP, but it is something I have to do, right? Yeah, I don't enjoy this. This is not working out. 50 minutes. Okay, I think that is enough. That is enough. Enough yapping. There has been a lot of yapping. Yeah, shit. And what is the outcome? I would have to solve latest, newer questions at 1200 and 1300 rating. And yeah, that is the only thing. And shit. This is the hard thing is because I was solving 1600 rated questions and 1500 rated questions, and now falling back to 1200 and 1300 just feels like too much pain to my ego. But yeah, I would have to do that. You're welcome. Yeah, those who have money don't prioritize it. Yo, he got you. I mean, right now I am enjoying coding because I am doing development. I think, hope it is the same doing DSA. Yep, you can hope so. And if it is not, just do it anyways. Just get out of this materialistic world, and you will see 20K a month is enough to keep you alive. Okay, I'm not saying that materialistic world is the way to live life. I'm saying if someone is materialistic, then it might be they are not a messed up human being. You cannot just say that they are a messed up human being. And should we are having a philosophical discussion, and I have like I have a higher bandwidth to get convey my thoughts, but you only have text to convey your thoughts. So this is very biased in my favor. So yeah, you are not able to get out your exact thoughts which you want to express. Yeah, that is also a factor. Shit, that is right. That is right. You will always feel not enough. Uh, yeah, just for that statement, you will be a moderator for a minute, 1 minute. Yes, you can flex a little bit. Your name will change. Shit, but do not kick people. Bro is delusional. No, bro is not delusional. He's also like being funny here. I can see that. Do not judge him. Do not judge him. And yeah, he has been here. And I guess at this point, I can say I know him a little bit. And yeah, do not judge him just from few text messages. That is nice. Like, yeah, that is not very nice. Shit, you are still a moderator. 1 minute, 58. Oh, nice. We will face a situation when who needs money, then you know whether 20k can keep you alive or not. Okay, you are referring to this fact that 20k can keep you alive. Shit, he is right now a moderator. He can ban you. Now he is not. Uh, we will face a situation when who needs money, then okay, we know whether 20k can keep you alive or not. I think just getting into the specifics, like speaking specifically, if 20k is enough or not, was not the intent. The intent would be, I guess, that not having a lot of money is not always bad. I think that was the intent when he said this were enough to keep my 3 generations alive. Shit, that is a subtle flex. Subtle flex. That from Varanasi. Okay, and shit, we are just like talking now, and the money that's talking. Yeah, I mean, yeah, but Pro has also worked hard. Um, I would say worked hard because he has Linux Bible. Otherwise, you won't. Yes. Hmm. Okay. Mm, uh, generally, this would be true, but you cannot say this for someone specifically, I guess, that it is money talking. Yeah, generally that would be true, but not specifically. I know what I'm talking. There is absolutely no need for me to be learning dev, and I won't ever apply. Yes, that, yeah, that is one of the things that you can say. Yes, there is no need for you to be doing. You have enough to keep 3 generations alive, but still, and yes, now you listen. This guy knows more about computers, you and me combined, and maybe all other people, all of the 5 other people combined who are watching this stream. And this is not easy to get to. You cannot even type on the keyboard that he is using. And he has this behemoth of a book which he reads from, this thing, and there are 96 pages available for free for preview. You can just imagine how long the actual book would be. The actual book is about more than 1000 pages long. Yeah, so he doesn't have to do these things, but he is doing these things. So yeah, that is nice of him. That is pretty nice. And yeah, we are just talking now, and that is not good. We should be doing something productive. And yeah, I guess I'll be ending the stream now. That would be cool. Yep. And that is the end of today's stream. I guess everything is nice. And thank you for being here. Bye.